Welcome to this lecture on cryogenic hydrogen technology. So, today we are going to start a new part of it, that is the hydrogen production. So, here in this lecture we will start with we will talk about hydrogen production, mainly the using non-conventional energy conventional energy resources, and these are the keywords: reforming, partial oxidation and autothermal reforming. And then to start with, let us first look at the basic of hydrogen production. What we have learnt earlier, that there are two basic means from which we can get the hydrogen. That is, hydrogen is when it is mixed in with oxygen, it is water and abundantly available in nature. There is other one when it is combined with the carbon and it is available in the form of hydrocarbon. So, if we try to convert this hydrocarbon for generation of hydrogen, we call it as fuel processing or reforming. And then the other one, if we are trying to get the hydrogen using water, that is the electrolysis process, and from both this we can have the hydrogen. But we will talk about this hydrogen electrolysis, production of hydrogen using electrolysis separately, but before that we will look into the reforming process, and both these processes are quite matured process. Both hydrocarbon reforming, generation of hydrogen from reforming process, as well as electrolysis, both are quite matured. So, we will try to look at them separately, and first of all, to start with, let us start with the hydrocarbon, and we have in general three type of hydrocarbons. Say maybe it is coal or in the solid form, in the liquid form it is heavy oil or crude oil, and in the gaseous form we also have the natural gas, and one of the major components of this natural gas is the methane. Depending on the well composition, there can be higher hydrocarbons, but mainly it is based on the methane. So, let us look into this, as we have learned earlier or talked earlier, that this coal is basically the one with which our industrialization started, and we have very matured or well established technologies with associated with the coal. So, but all these three form of energies, be it coal, crude oil or natural gas, these are the fossil fuel. Now, these are some of the primary sources of energy. So, let us look into it in a different aspect. The generation of hydrogen using the non-renewable energy resources. So, this is these are the primary energy resources, as I told you, that the natural gas or petroleum products, then we have the coal, and then there is another third form of energy which we have not talked about so far, that is the nuclear energy, and this will come in picture later on when talking about the thermochemical processes and generation of hydrogen using thermochemical or high temperature thermochemical reactions. So, these primary sources of energy gives us the secondary source, that is the electricity. Basically, from this all is using all these resources, primary resources, we are generating the electricity. Again, electricity is something is not available freely, it is again an energy factor derived from the primary energy resources. But unlike hydrogen, this electricity, storage of electricity is bit challenging. It can also be stored. It is not like that we cannot store electricity. We need special devices, superconducting magnets, to store the electricity, but that is again another big challenge. But if we are generating hydrogen from this primary and the secondary energy resources, hydrogen can be stored in different means for a quite long time. Now, let us look into this secondary energy, and from there we can look into the conversion techniques for generating the hydrogen. So, from natural gas and petroleum products, we have three basic processes like partial oxidation, steam reforming and autothermal process. And from the coal, there is again another process called gasification. We will be talking about it later on. And from all these processes, say this primary energy is used for generating the electricity, and from electricity we can have the electrolysis of water. And so, basically this water will be used in all these three processes. So, maybe in the form of steam or in the form of say water, or in these two forms it will be used to generate hydrogen. So, these are the non-renewable energy based hydrogen production. So, this non-renewable energy are quite abundantly available for still we have a quite a good reserve of coal, but that is depleting quite fast in some of the regions or countries. And we have to, as we have learned earlier, that we need to look into the non-renewable energy resources. That is let us look into that aspect. So, what are the non-renewable or renewable energy resources we have to look into? So, renewable energy resources are the primary energy resources are the biomass, and then we have the solar, and then the other like wind, thermohydraulic and geothermal, and there are some wave based or tidal generation, tidal energy for generating the electricity. So, the secondary energy, as we have learned that all these energy resources can be used to produce the electricity. So, if we are producing electricity, again the conversion techniques, as we have learned earlier, that electricity can generate electrolysis using the water, and this biomass can again be steam reformed and along with the gasification, and this solar energy can also produce thermal it can be stored in the form of thermal energy to generate the biophotoelectrolysis and a series of other photocatalytic thermolysis, etc. But most of these processes are in the R&D level or research. No commercial generation of hydrogen in the commercial scale is not that much popular. So, all these energy resources, these conversion techniques are generally giving us the renewable hydrogen. So, using all these processes are again using water in the form of ordinary water or steam or hot water, and we are getting the renewable hydrogen from these processes. So, we have to look into these processes. Of course, these are the if hydrogen is to be used as a future fuel, we must look into the development of or maturing these techniques where this energy will be primary energy will be from the biomass, solar or the wind or the hydroelectricity. But at the same time, we have to, for immediate application of this hydrogen technology, if we have to use in near future for hydrogen as the fuel, future fuel in near future, we must look into the non-renewable energy based hydrogen. So, that is a primary component of non-renewable energy is basically the coal. So, what are the advantages of coal? It may look a bit odd that we are talking in favor of coal, which produce so much of CO2 that we have learned, but there are certain positive aspects of this coal. Let us look into this. Basically, this is very low cost energy resources, and it is available in some of the regions and parts of this globe, and that can sustain even up to, it is estimated that for another 200 years it can be producing the energy. But another important part, as we have talked earlier, that since coal was the element with which this our industrialization started. So, there are technologies which are quite mature technologies, and we have the technologies available with the vendors. So, we have quite a bit of learning about the excavation of it or transportation of it, because most of the time you will find that the coal based or the thermal power generation is located very close to the coal mines, and or maybe it is within, they are connected with the rails transportation. So, these infrastructures are already available with us, and it can sustain, or it can give us hydrogen production for the midterms up to quite a reasonable amount. So, the production of this hydrogen is at this moment, if we are producing it using the coal, it is the lowest. So, low production cost of hydrogen, and as well as the low coal cost is the two attractive features for the generation of hydrogen using coal. And what are the technologies that are to be improved, or what are the limitations of this coal energy or this hydrogen generation using coal is also known to us. So, it is to be implemented if it can be taken into account. So, this can also be a good potential source of hydrogen energy. So, it can have, as I told you, it can be a potential source of hydrogen generation in near future, till we have quite compatible energy resources using the renewable energy based hydrogen production. But as we have already it is also known that there are quite a few negative features, and one of them is the CO2 generation. So, it is having the highest CO2 emission among all the non-conventional energy resources, and already we have learned about it that the carbon to hydrogen is quite high with coal. It is nearly about 2 to 2.5. So, when we are converting this coal into the generation of the hydrogen, we need to produce the CO2, that we will look how we know it can be carved or it can be captured. So, we need a technology development associated with the CO2 capture as well as sequestration of CO2. But at this moment CO2 emission with the hydrogen production associated with the coal is highest. For in terms of say energy, if we have to generate unit energy using coal, nearly we need about 80% of more CO2 generation as compared to the natural gas. If we have to generate same amount of energy out of coal and out of natural gas, this coal will produce nearly 80% more CO2. Nearly about for 1 kg of hydrogen, if we have to produce, we generate nearly 19 kg of hydrogen 19 kg of CO2 with the coal, and compared to that if we have to generate 1 kg of hydrogen using natural gas, then we it is cogeneration of CO2 is about 10 kg. So, these are the kind of figures we have to keep it in mind at this moment, that 1 kg of hydrogen will generate nearly about 10 kg of CO2 with NG and natural gas, and nearly 19 kg of CO2, with the present technologies available with us, it will give us of that sort of CO2 generation. But it will also have the environmental impacts like associated impacts like soil erosion would be there, land distribution disturbances would be there, then dust and waste piles and abandoned mines. All these are creating problems with the environment, and these are it is already there with the excavation of coal, and we have to definitely curb the use of coal in future. But so long as these other technologies are not getting matured, we can probably think of using it with the CO2 sequestration and capturing. Okay, so now before we try to understand the advantage of using coal and what can be done or improvement that can be done with the use of coal in future, let us look into the steam reforming, as we have learned in the previous slides, that there are quite a few processes when we are changing the hydrocarbon from hydrocarbon to hydrogen. We have talked about the steam reforming, and then we have talked about partial oxidation and autothermal reactions. So, let us look into those reactions, what exactly is happening in that processes. So, steam reforming reaction is basically meant for the light feedstock like natural gas, LPG, naphtha, etc. So, the reaction, if we look into the primary constituent of natural gas, that is the methane, and the reaction would be something like methane plus water. It is not water, it is in the form of steam, and it gives us the syngas. Syngas is basically a combination of CO plus hydrogen. So, it is called syngas because our synthesis gas, popularly known as syngas, it is the basic of or basis of many hydrocarbon or products which are produced in the chemical industries. So, this is what is syngas, and this is basically an endothermic catalytic reaction. So, this catalytic reaction and quite a bit endothermic. So, you can see that the enthalpy of reaction enthalpy is nearly 2006 kilojoule per mole, and it is quite high, and we need to supply good amount of heat into this process. So, this endothermic process and catalytic process, we need to have adequate precautions that we will talk about while talking about the process in details about the steam reforming reaction. So, we need to be careful about selection of the catalyst and pre-treatment of the catalyst of the feedstock. So, that some of these catalysts are very sensitive to some of the components in the feedstock. Okay. So, this is about the primary constituent of natural gas, that is methane, but with the higher hydrocarbons, this would be like a generalized reaction, you can say, in CnHm, that will also give us the CO plus H2, and this is what is, as we have learned, is the syngas. There is along with that, this is you have to, as I told you, that this is an endothermic reaction. We have to supply energy in the presence of some catalyst, and this this water that is in the form of steam, and along with that in the bed there is a another reaction side by side happening. Actually, this CO will also react with the water. So, to produce CO2 and H2. So, this will of course enhance the H2 concentration into the product, but there would be cogeneration of CO2, and this reaction is basically slightly exothermic reaction. So, it can be understood from the sign of this reaction enthalpy. This is minus 41 kilojoule per mole, whereas since this reaction enthalpy is positive, this is endothermic reaction, this is exothermic reaction. So, this is an exothermic reaction, it will slightly produce heat, and we call it as water gas shift reaction. So, this water gas shift reaction will generate hydrogen that will increase the quantity of hydrogen in addition to this 3 H2 that has been producing the steam, and I mean with the help of steam it is generating CO and H2. Along with that we have the water gas shift reaction. So, the overall reaction would be something like CO plus CO2 and H2. So, H2 content will be higher. So, this is what is steam deforming reaction. Let us now look into the other one, that is called the partial oxidation. So, in case of partial oxidation, we use the feedstock is basically the heavy oil, pitch, or often it is the coal. So, with the partial oxidation, we can use this is a generalized equation, you can say, that is with the higher hydrocarbons, and it is producing CO and H2 again, and this is again you can understand that this is the syngas, or I mean basically it is the synthesis gas, from there we call it as syngas. So, this syngas CO and H2 combination is produced as we have understood that this is coal or heavy oil or pitch, and this is we have taken pure oxygen in this reaction. So, that means you have to separate this oxygen from air. This I think it is worthy to tell you that this O2 comes always most of the time from air, and there we separate this air into its component, I mean two constituents, oxygen and nitrogen, and there is a lot of cryogenics in it, that is the cryogenic distillation is used to separate this air into its constituent nitrogen and oxygen. So, that means there you need additional energy or cost to generate this oxygen, separating air into its constituents, but there is an advantage, we will talk later on about it. So, if we are using oxygen purely, I mean this can come from air itself, and what I mean is that one can also use directly air, and that air will be coming over here and it will be mixing with that inert N2. Along with that the product of CO and H2, you will have this N2 as in your it will be mixed with your final product, and if you need hydrogen, eventually you have to separate the CO, and also you need to separate nitrogen from this process. Okay. So, that is about the primary reaction that is happening with the partial oxidation, and one can also think of using what is called the methane here, or the natural gas, though it is said that the partial oxidation is mainly recommended for heavy oil or the coal, one can also use methane, but one has to compromise with the COH2. I mean when someone needs or less amount of CO plus H2, and also one has the availability of oxygen, then it can be thought of. So, here this reaction partial oxidation in contrast to that steam reforming process, this is exothermic in nature, as well as this does not need any catalytic presence of any catalyst. Okay. So, that means this is non catalytic reaction, and it is exothermic in nature, and sometime of course, we as we have written here that steam addition is needed, particularly with the liquid feedstock and its atomization. So, that is about this reaction, and with the natural gas, as I have told you that it needs oxygen, and with this oxygen CH4 will generate CO and H2, and from the reaction enthalpy you can understand that it is exothermic in nature. But what happens if oxygen is used in excess? So, if it is oxygen in excess and if we are burning the coal or the heavy oil, we will find it is generating the CO2 and H2O, but there is no H2. So, that means it is basically generating the CO2 and water, but there is no hydrogen in it. So, and this reaction is heavily exothermic in nature. So, this is about the partial oxidation when happening in excess of oxygen, and this partial oxidation when it is having in presence of less oxygen, it will generate of course, the hydrogen. You can see that it is generating hydrogen, but there would be lot of soot formation. So, basically we have not only that soot formation, but along with that we have the low outlet temperature at the exit of the partial oxidation reaction. So, next is autothermal process. As you can understand that it is basically a combination of partial oxidation and steam reforming, because if you look at these two reactions, steam reforming is endothermic. Endothermic is basically where you need energy, and partial oxidation, as we have understand that this is exothermic. So, we are trying to combine this exothermic and endothermic reaction. That means, initially this partial oxidation will generate the heat, and that will be used to create this steam reforming, and that is what is called the autothermal reforming process. So, we will talk about these three processes, how they are happening, and this is of course, this steam reforming is catalytic process, this is non catalytic process. So, we will see how these autothermal reformers are made, and these are the some of the references, and you can go through this literatures or read these books for this lecture. And so, let us try to conclude that we have non renewable hydrogen generation we have talked mainly today, and out of that we have talked about the steam reforming, partial oxidation and autothermal reforming, whereas the steam reforming process is a catalytic process and endothermic process. This partial oxidation is non catalytic and it is exothermic. So, we have to take advantage of this, and finally, the autothermal reforming is the combination of steam methane reforming and partial oxidation. So, thank you for your attention.